All right, so today, if you are finishing a test, you got to finish that test, okay? That's a couple 2-3 days after we took it, so it really needs to get done so we can grade that and go over it, hopefully tomorrow, right? But today we progress forward into the next notes for the next unit. We're going to be doing right triangles and trigonometry, Pythagorean theorem, all that good stuff. However, we are going to start with the basics, and you have to know what to do with radicals or square roots, okay? So your little warm-up is to make sure you've done these two little tables, and we're going to go over that right now. But again, finish your last test if it's in front of you. You can catch up on the notes later, okay? Oops. So, here we are. So, perfect squares. Just start at the very top. Simplifying radical expressions, part 1. When working with the simplification of radicals, you must remember some basic information about perfect square numbers you need to remember. And let's remember. So 4, like we had earlier, is 2 squared. This is going to get real easy real fast because the pattern is obvious, right? But 9 is what squared? 3 squared, right? So we know 3 times 3 is 9, and for 16, we know it's 4 squared. 4 times 4 is 16. Hopefully you know that, right? These are things you want to be able to visually connect in your mind. So if you see 25, you know that's 5 squared. You see 36, you know that's 6 squared, okay? And so forth. 49 is 7 squared. 64 is 8 squared. 81 is 9 squared. Okay. 100 is 10 squared. 121 is 11 squared. Okay. Now that's not too hard because it's obviously ascending by 1 each time. Also, we want to know how to work backwards. So if you see those big numbers that were on the left-hand side, okay, and you see this radical, and you know what a radical is, right? It looks like this. We call it a square root sign or a radical. If you see the square root of 4, then you're working backwards. What times what is 4? Well, 2. What times what is 9? Square root of 9 is 3, right? Square root of 16. What times what is 16? Come on. 4, and then so forth. So square root of 25 is 5. Square root of 36 is 6. 7, 8, 9, 10, 11, obviously, but I want you to actually notice that it's working backwards from the squares. So as we do this, you got to know that a square root is the opposite of square, okay? If you square a number, you can undo squaring a number by square rooting a number, okay? So now we are actually going to simplify a radical, okay? Now I'm going to show you a method called factor tree. Oops, let me move that back. Yeah, so here we go. Simplifying a radical. I'm showing you the factor tree method. Hopefully you've seen that before, maybe not. Some other teachers teach the cake method. There's no cake involved. So, yeah, here we go. So we're going to do factor tree. You can see the steps over here, step 1, 2, 3, 4, and 5. Okay, you can read them, but instead of just reading them, that'll take some time right here. I'm going to show you how it's done. Okay, so everyone, focus now, understand it now. Okay, too many people blow off the notes and then they're left on an island wondering what's going on when they get the assignment. So again, if you got laser focus now, you'll be solid. Now, everyone sees example 1. It says square root of 50 right here. Okay, so what we're going to do is we are going to make a factor tree. Raise your hand if you've ever done a factor tree. Okay, got some hands, great. So you're trying to think of what number goes into the number under the radical. So we're going to think, what goes into 50? What can you divide 50 by? And I want you to think of the smallest number, that's not 1, but greater than 1, okay? What's the smallest prime number is what we call it, that goes into 50? So above 1 would be 2, right? Does 2 go into 50? Yes, anytime you have an even number, you're going to use 2. Okay, so here's what we're going to do. Make a little branch, okay? Now, we call it a factor tree. I'd say it's more like factor roots because it's going downward, but whatever you want to call it, right? So what I'm going to do is write 2, and then I'm going to think times what is 50? 2 and 25, right? So that's good. So that 2 is what we call prime. I cannot break down 2. Some people think, well, yeah, you can break down 2 into 1 times 2. we're not going to ever use 1 when we do a factor tree. Okay? So 2 is done, because that's the smallest you can go without using the number 1. So we call that prime. Okay? 25, though, we need to break that down, because that's not prime. 25, what times what is 25? What's the smallest number that goes into it? 5, right? 2 doesn't go into it, 3 doesn't go into it, but 5 does. So 5 times 5. Now, we're thinking, does 5 break down? No, it doesn't. So we have finished the factor tree. Now, I'm going to give you some tips not to get confused, okay? Some people get confused because they see all these numbers and they think 25 and 50 are numbers we're going to use. Anytime you break down something, whenever you make that tree, it's a good idea to cross these out. 50 is gone. 25 is gone. The only thing we care about is 2, 5, and 5, okay? Now, I'm going to tell you a story, okay? Y'all like stories? Story time with Mr. G, right? Everyone loves this. It's one of my favorite parts of the year, okay? We get to talk about the radical party. How many of y'all went to like a radical party this last weekend? What? So, radical. So, here's the deal. We have a radical party, radical house party. So think of this radical sign like a house, okay? You got all different types of prime people that are coming to this radical party, right? And so, I see got a 2 and a 5 and a 5. Now, guess what? You know, it is what it is. It's a party. So, there's 2 numbers at this party that they're just so alike. They're just like a pair or like a couple, right? So, here's what I'm going to do. I'm going to circle my pair. I got a pair of 5s. They're so alike, they just connect, you know? They're like, hey, you want to be my GF? It's like, hey, you want to be my BF? And then there you go. So now they're a pair, right? But it's so sad. There's a tragedy that happens. Okay? The couple, they think they're too cool for this radical house party. And they're going to leave. They're saying, we ain't hanging out inside. We're going to go outside. Okay? We're going to go, I don't know. But they made a bad, one of them made a bad decision on the way out. You know, they shouldn't have been intoxicated, and they got in a car, and then unfortunately one of them did not make it home that night, and it's so sad. And I'm also commenting on things we should not do as high schoolers, because we have brains and we're not going to do silly stuff. So here's what I want you to do. Whenever we have a pair, one of them is tragically gone. Oh, it's so sad. It's a tragedy, all right? So, but seriously, when you circle a pair, you cross one of them out, because I don't want you to get confused, okay? When I tell you to cross something out, it's so you don't get confused. So when you circle something, cross one out. So here's the rule. Couples leave the party. So they're going to go outside. So here's my outside, and here's the inside, right? So just so you know what I'm talking about. So everyone was in this house party, right? We had a square root of 25. But now, who goes out? The 5, okay? Because the pairs are going out. Get it? Ha, ha, ha. Going out. Because they're a pair, they're a couple, they're going out. Okay, so you get the idea. So the pair goes out, but you don't write 2 5s. You write 1 5. Okay, because it's so sad. One of them's gone. All right? And guess who stays at the party? The loner. It's so sad. He's all by himself. All right? So the 2, loner, is staying in. Okay? But the pair or the couple goes out. Pun intended. Radical party. Pairs go out. Ha, ha, ha. Okay? Whatever it takes for you to remember this stuff. Okay? So, again, when you make a factor tree, make all your factor tree, cross out the ones you broke down, circle your pairs, pairs go out, loners stay in. That's the rules. Okay? So, this gets maybe more complicated if you have more than one pair or more than one loner. I will show you what to do. But the answer to any time you have more than one thing is you multiply. So let me show you. Look at example 2. So by the way, the final answer to number 1 was 5 square root of 2, and that's it. So what is the square root of 50 equal to? 5 square root of 2. Okay? Notice how I did not just type it in the calculator and get a decimal. We're not talking about decimals today. We're talking about reducing radicals. So, up here, example 2. Square root of 24. What is my first step? What am I doing? Making a factor tree. So I'm thinking, what's the smallest number that goes into 24? before 3, 2. It's an even number, okay? So always see if 2 works first. And 2 does work because it's even. So 2 times what? 12, okay? I'm going to cross out that 24. 24 is done, okay? Now, let's find out. Does 12 break down? It's even. So what goes into 12? 2 times 6. Cross that 12 out. We don't need it anymore. 6 is also even. So guess what? 2 times 3. Cross that 6 out. Okay? Now, I have 4, what I call them prime factors. So I'm going to, again, I'm going to ask myself, are there any pairs that I can circle? Do I have any pairs? I do. I have a pair of 2, and that's it. Okay? Do you see the leftover 2 and 3 are not a pair? They're kind of alike, but they're just not compatible. They don't work. It just didn't work out. All right? So again, the only ones you circle are exactly the same. Now remember, it's so sad. One of those 2's is gone. So sad. Now, let's think about our radical house party. What's going to go out? The circled or the non-circled? The circled, because the pair, the couple, is going out. Right? So, I'm going to put 2 right here. Now here's something new. I got 2 loners, 2 and 3. Okay? Anytime you have more than one number, you multiply them. So don't add them. It's not 5, right? 2 times 3, multiply these terms, we get what? 6. Okay? Do you see how that works? You have to multiply when there's more than one thing going out or staying in. Okay, so that's my example 2 was 1 pair and 2 loners. Now you know what to do with that, right? Let's try example 3. 180, that's a big number, but we can do it because we are going to do prime factors, right? So, is 180 even? Yes, it is. So let's break it down by 2. Very good. So 180 is 2 times 90. Very good. 90 is also even, so it's going to be 2 times 45. 45 is not even, so what's the next biggest number after 2? 3. Does 3 go into 45? Now, if you don't know, that's when you can utilize your calculator, divide 45 by 3, see if you get a whole number, and you do, okay? So, it's going to be 3 times 15. Okay? Does 15 break down? So, 15 does break down, and actually 3 goes into that. So, 3 times 5. Now, everything I broke down, I forget about it. I don't want to get confused, so don't worry about that stuff. Do I have any pairs? Pair 02, pair 03, and a loner 5. This time we have 2 tragedies. It's so sad. Goodbye 2, goodbye 3. Okay. Now, I got 2 couples, and they're supposed to both go out. Okay, so here's my radical house party. So the 2 and the 3 that are going out, what do I do with them? The answer is always multiply. So it's not 5. 2 times 3 is 6 on the outside. The pairs go out. Okay? And then the leftover, the loner on the inside is 5. Okay? 6 square root of 5. Do you see how we do this? Okay? This is the factor tree method. Break it down, break it down, break it down. Circle your pairs. Pairs go out. Loners stay in. If you have more than one, you multiply. Okay, so we still have, so that was a 2 pair, 1 loner. Okay, if you flip it over on example 4, what if we have 2 pairs and 2 loners? Let's find out. Now, 1260. If you see a big number, don't sweat it. Just break it down. So, 1260 is even because it ends in a 0, so that's 2 times what? 630. Ends in a 0. That's even. So that's going to be 2 times 315. Now, if you don't know this already, there's kind of an easy way to tell if a number is divisible by 3. Because the question is now, since it's odd, it's not divided by 2, but does it divide by 3? Now you can always check on your calculator, or you can do this. What's 3 plus 1 plus 5? 9. Does 9 divide by 3? Yes. So this divides by 3. Okay, it's kind of a little trick. If you add up all the digits, if that number divides by 3, then the whole number divides by 3. So if that didn't make sense, don't worry about it. Just use your calculator. 315 divided by 3 is what? 105. Okay. 1 plus 5 is 6. That's divisible by 3. So 105 divides by 3. 3 times what? 35. Now 35 does not divide by 3, but it ends in a 5, so it divides by 5. 5 times 7. Okay. Now if that was too fast for you, you can just try numbers in your calculator. But I always want you to try 2 first, then 3, then 5, then 7. Okay. Prime numbers, numbers that cannot be broken down. So again, I'm going to get rid of these numbers that are gone. All right, so my pairs are what? Pair of 2, pair of 3. It's so sad, and it's so sad. All right. So pair of 2, pair of 3, they're going out. So I got my radical. The 2 and the 3, we do what with them again? Multiply. On the inside gives me 6. The 5 and the 7 loners left over, what do we do with them? Always multiply. 5 times 7, 35. So if anyone asked you, what is 1,260 reduced radical form, you would tell them 6 square root of 35. Okay? So you see how we're doing this. We're going to use this in the future, so that's why you got to know this. We're laying the groundwork. Example 5. Now, the big difference about example 5 is there's already a number out front. So what do you do with that? The answer is always multiply, but I'll show you. Okay? So 76. Let's break it down. This ends in a 6. That's even. So it's going to be 2 times 38, if my mental math is correct. 38 is also even. So it's going to be 2 times 19, I believe. Okay. Does 19 break down? 19 does not. We call that prime. Okay. So what I'm going to do is, again, 76 is gone. 38 is gone. Circle my pair of 2. It's so sad, 1's gone. Now, I want you to remember, the pair is going out, right? Do we already have a number outside? Yes, we do. If it helps you to remember, it might be a good idea to circle that because that's already out, okay? So technically, you have a 5 already out, a 2 that's going out. What should I do with 5 and 2? The answer is always multiply. So 5 times 2 on the outside is 10. On the inside is 19. And I'm going to tell you, the most common answer that's wrong that I'm going to get is this. Because people are, I'm telling you, if there's anything you're going to forget, it's the number in front at the beginning, that coefficient 5. So anytime you see it, it might be a good idea to circle it so you don't forget it. That way you see, oh, hey, there's 2 things circled. I got to multiply those things, okay? Now, I tried to show you every type of example. Okay, the only one I didn't show you is if it's already a perfect square. Okay, like if you, let's say you're doing square root of 121, and you do 11 times 11, and you're like, wait, there's no loner. So let me just tell you, if there's no loner in your square root, then you don't put a square root. Okay. Like the square root of 121 is just 11, so you don't need to put a square root there, right? So again, if you find yourself with no loner, then the square root goes away. It's just a number. It's just a whole number, okay? But if you get stuck when you do that, we'll talk. Now, so I want you to try these on your own. Practice makes perfect. So be careful on 5 and 6 for those coefficients. Okay? So I'm going to give you 5 minutes. See what you can do. Okay? And we'll see how much more of the notes we can do. So let's try that. Okay, if you got questions, that's fine. I want to show you two problems that a lot of people have questions on. Make sure we're getting it right. Look at number 4. On number 4, I'm assuming you'd be able to say, hey, that's even. 2 times 35. And then 35 ends in a 5, so that's 5 times what? 7. 70 and 35 go away. Now, is everyone looking up here? Okay, so I know you might be doing a problem. Okay, but what's weird about this? No pairs. Okay, now the only way you can leave the radical party is if you're a couple or a pair, right? So here's the deal. No pair, leave it alone. Okay, meaning your answer is actually what you started with. You can't change it unless you have pairs. So again, if you have no pair, then you leave it alone. It's just a square root of 70 on number 4. Now, look at number 3. 3 might, if you do it the way I'm telling you, it might seem weird because check out number 3. 2 times 18, 2 times 9, 3 times 3. I know I did that really quick because I'm trying to show you. Look at this. Pair of 2, pair of 3, what's missing? There's no leftover. There's no loner. If there's no loner, then there's no radical. Here's what I mean. 2 and 3 go out and multiply, and it gives you 6. You don't have to put radical 1 or radical nothing. You just put 6. That's it. And if you look at the problem, didn't you already know that the square root of 36 is 6? Hopefully. If not, I'm telling you, if you do a factor tree and you have no loner, that means you have no square root. Okay? You just multiply your pair. 2 times 3 gives you 6. Another one that's kind of tricky for some people, look at number 5. 54 is 2 times 27. 27 is 3 times 9. 9 is 3 times 3. Now, what are my pairs on number 5? For sure we have a 3, but here's the question. Some people might say, hey, I have 2 on the outside at the beginning and a 2 prime number down here. So here's the question. Can you circle an outside number and a factor tree number? No. Okay, so I know these look like they match, but you can only circle stuff below in your factor tree. Okay, so again, kind of think about below 54. That's the only stuff you can circle. Okay, so the only pair I have is a 3, and on the outside I have a 2. So what do I do with those? 3 times 2 gives me 6. And then the leftovers are 2 and 3, which also gives me 6. Now, I can answer questions on that if that didn't make sense, but just remember, circle stuff in the factor tree only, okay? And then multiply that with the coefficient outside. So you can come back to those try on your own problems. I do want to start the multiplication of radicals on the next page. So let's go ahead and flip it over real quick. This should be kind of easy, in my opinion, okay? It says when you're multiplying radicals, one must multiply the numbers outside and then multiply the numbers inside the radical. So it's just easy. Outside multiplies with outside, inside multiplies with inside. Okay? So 2 times 6 is 12. 3 times 2 is 6. That's it. Easy? Outside with outside, inside with inside. However, look at example 2. Outside and outside. 3 times 4 is 12. Square root. Now what's 6 times 2? 12. Now here's the part where you have an extra step. Can we break down 12 like we just learned how to do? Let's find out. 2 times 6. 2 times 3. Do I have a pair? Boy, howdy, I got a pair, right? Pair of 2. Cross that 2 out. And this 2 is going to multiply with this 12. So on example 1, 6 was just 2 times 3. There's no pair, so you leave it as 12 square root of 6 for sure, okay? But over here, 12 times 2 is 24, and my loner is 3, okay? So do you see how we're doing multiplying, and then we have to ask ourselves, can we break it down? Can we reduce the radical, okay? So I'm going to let you try that on number 1 and 2, and we'll get to the next part next time, but let's try that, okay? Give you 5 minutes, try that, and if you finish it, go back to those radicals if you didn't finish any from the prior page. Real quick, on the bottom, every time you multiply a radical by itself, it equals the number inside. So these should be really easy. Square root of 2 times square root of 2 is 2. We're not going anywhere yet. Square root of 12 times square root of 12 is, guess what? 12. Okay? Does that make sense? If you have a square root times itself, it gets rid of the square root. It's just the number underneath, okay? So real quick, on number 1, 4 times 3 is 12. Square root of 5 times square root of 5 is 25. Did you notice how you had no loners here? So if you have no loner, you multiply 12 times 5 and you get 60. There's no square root. Okay?